Welcome to the third and final video in our review of natural log and exponential function from Calculus 1. So the last two videos dealt with the natural log function, with it being the area under the curve. So if you look at the area under this curve, x, remember, can move around. At some point, x can be in the perfect spot that this area is exactly 1. Right? We know if x is 1, I have 0. And then as x gets bigger and bigger, it goes off to infinity. So at some point, I get an exact value of 1. Mathematicians chose to call this spot E. It's not a rational number. It's not a nice number to write down. It's like pi, so we have to give it its own name. So mathematicians chose to call it E after the mathematician Euler, who was a brilliant guy. You should look him up, read about him on Wikipedia. All right. So, and it turns out E has those properties you're used to. It's the base of the logarithm. You can rewrite the log as an exponent with E as the base, yada, yada. Okay. So let's look at some things involving E. All right. We know that anything to the 0th power except 0 is 1. So e to the 0th is 1. Anything to the first power is itself. So e to the first is e. Natural log of e, we just said e was specifically picked, okay, to make that 1. All right, so let's take these first two and look at the graph of e to the x that you're used to from high school. Okay, so we can see my spot there where e to the 0th equals 1. And at some point in here, right, e to the first equals e. Okay, e to the x ends up being a super important function in mathematics because its derivative is itself. So we want to look at why that's true. Your Calculus 1 teacher may have gone through it, but it's important enough to see it twice. Okay, so let y equal e to the x. If I take the natural log of both sides, I get natural log of y equals natural log of e to the x, but that right-hand side simplifies down to x. Okay, you can pull that exponent out, and natural log of e is 1. All right, now I'm going to use implicit differentiation on this. So the derivative of natural log of y is 1 over y times y prime. The derivative of x is just 1. So the natural log of y gave me the derivative 1 over y times y prime. The derivative of x gave me just 1. So I can rearrange this equation, multiply both sides by y. We get y prime equals y. Well, that's exactly what we were looking for, right? Y is e to the x. So this is saying the derivative of e to the x is simply e to the x, okay? Favorite formula you'll have to memorize for calculus. So let's write that down in a useful form. All right, so the derivative e to the x is e to the x, and the integral of e to the x, the antiderivative of e to the x, is e to the x plus c, okay? And hopefully you remember those from Calculus 1. So like before, we're going to practice. We're going to do 2 derivatives and 2 integrals. I recommend you pause and try to work them first before you watch me work them. Okay, practice problem number 5. So I see here I have a function inside a function, right? My inside is 4x, and my outside is the e, so it's chain rule. So chain rule says keep the outside function and take its derivative, keeping the inside the same. My rule for e to the x is it stays the same. Then multiply pi the derivative of the inside, which is 4, because the derivative of 4x is 4. So we get 4e to the 4x. You need to get to the point to where you can do these derivatives super fast. So if it had said e to the 3x squared, you should be able to just jump in and say, oh, that's going to be 6x e to the 3x squared. Okay, that'll save you so much effort as you do more and more complicated problems. Okay, next one. We have e to the p sine p. So here I do not have a function inside a function. I have a function times a function. So that means I need product rule. All right, so product rule says derivative of one, keep the other the same, and then you flip and add. So derivative of e to the p is e to the p. Keep sign the same. Now, derivative of sine is cosine. And keep e to the p the same. Right? So derivative of e to the p, keep sine the same. Derivative of sine, keep e to the p the same. All right, now it's just a matter of writing our answer nicer. There's really not much else I could do. Most books will factor out the e to the p because it saves on ink and write it this way, but either way, valid answer. Okay, so that's derivative practice. So now let's practice some integrals. All right, again, our only tool is substitution, so we're going to need to find a u that works. So there are a couple different options on this first one, actually 2 different options that will work. Typically, the easiest one for people is to let u equal v cubed. Okay. Then my du is 3v squared dv. So there I have the 3v squared, there I have the dv. Those will join together to make a du. If you're using u's and v's, be very careful that you can tell the difference. Okay, and that v cubed is going to become u. So let's rewrite our integral. So this is going to be, let's see, the 3v squared was used in du, so it's not there. The e is still there, but his exponent became a u, and everything else got used to make du. Now, this is an integral I can do. It matches my formula exactly. So I get e to the u plus c, because that's what my formula says. It doesn't change. So then I have e to the v cubed plus c. Final answer. All right, let's look at the last problem. So again, substitution's all I got. So let's do that. I need to find a good u. I don't like having craziness in the denominator, okay? And at this point, you may not be comfortable dealing with that. So let's let our u be 1 plus e to the r. And hopefully that'll bring my denominator in to make it just one nice u. Then du, well, the derivative of 1 is 0. Derivative of e to the r is e to the r dr. And this was set up perfectly, so I can take the e to the r and the dr and create du, and that denominator is going to be replaced with a u. So here we go. So numerator, everything got used, so it's a 1. Denominator is a u, and I have a du, because that's what all the pieces got absorbed into. That's what they were used in. All right, that matches my natural log formula exactly. So I get natural log of u plus c, which gives me natural log 1 plus e to the r plus c. Since 1 plus e to the r is never negative, you could get rid of the absolute value signs and replace them with parentheses. Doesn't matter. Both mean the same thing. So that's a review of natural logarithm and the exponential function.